Hello, June 28th. Let's just get this done. Maximum total importance of roads. Given an integer n denoting the number of cities in a country, cities are numbered from 0 to n-1. You are also given a 2D integer array roads, where roads I, AB denotes that there exists a bidirectional road connecting A and B. You need to assign each city with an integer value from 1 to n, where each value can only be used once. The importance of a road is then defined as the sum of the values of the two cities it connects. Return the maximum total importance of all roads possible after assigning the values optimally. So in this case, the importance is the sum. So you want the node that has the most connection to be getting the highest value. So you can count 4 times. Right, 2 is 4 times, so you assign 5 to it. 4 times 5 is 20, right? And this is 3, so it's 32. This is 2 times is 39, and plus 4. 39 plus 4 is 43, and do one more time. This is 20, 32, 38. Right, 38, 42, and 43. All right. Oh, it might not be that's fine. We just need to find the nodes that has 1, right? So it's like a topological sort. We go through this, and at the end we will find the ones that has size 1. So you pick those out, right? They have size 1, and they will be assigned. Doesn't matter, you just assign them, right? 1, 2, 3, however many you do that, and then the next one you do will be assigned. So those will have like 2, right? 2 connections. And 3 connections. Okay, so let's try this. The question, I have only one question left. What data structure I'm gonna use? Because we need to remove, so it has to be a set, right? And I might as well just use a map. We can say map integer and set graph for edge, call it E, plus graph dot put if absent. Key is going to be E0, value should be new hash set graph dot put if absent e1 should be a new hash set, and then graph.get e0 dot add e1 graph.get e1 dot add e0. Okay, so that's that. Then we need basically a queue. So we use a deck queue. Array deck. Okay. Then we say, just go through for set integer nodes v's of graph dot values. Okay. If vs dot size is equal to 1, then q dot add, let's say add last. Oh, I need the keys. Okay, so it's a bit different. So we say int key set, and this is going to be graph.get key, and I will put key in it, right? Okay, so now this is int res equal to 0, int count equal to 1. Okay, so I see. Yeah, I think you should go with them. I should go with them. So instead of an integer, I should be int at last new int key and 1. I don't need this, right? And I say while q dot is empty. Right, if it's not empty, then we say int current equal to q dot pop left, remove first, rest of plus equal to, and then the current value, score, imp, start with 1, right? Should be imp times current 1. Right, we basically handle 1, and we will go through this. We'll go through everybody in current. Right, we'll go through everybody in current. We find it, and I'll remove current from it. And yeah, so we're gonna say for int child of graph.get current 0, right? And then we say graph.get child. Nah, it's really not child, it's just neighbor. Right, neighbor dot remove current 0 if graph.get neighbor size to 1, then q dot add last new int neighbor, and the count is going to be current 1. But you can go through the same thing, right? Huh. Yeah, we're not, we only include it, but how many times are we removing it? Right, you don't know. So we need another one, like a counter. Right, we need a counter. Okay, so I think we need a counter, which will make things easier. 5 to 10 to the 4th. So we can do a counter, right? Yeah, so we can say int counter new int 50,000. Right? That's what the node is. N minus 1, so 50,000 should be enough. And then we say the size counter k equal to graph.get k.size. Yeah, there's a counter. Now we have this, right? Though, yeah, we can remove and that I don't need. I have the count, right? I have the count. Yeah, I have the count. So this I can just do integer. Then we just put k into it. This I still need. This is not necessary, or remove, and current is just the key, right? So this shall multiply by counter current, right? And if a neighbor in current or remove current size equal to 1, then we'll add neighbor, right? So after we handle 1, imp plus plus implementation importance, right? So next one, yeah, next one until it becomes 1, then it will go out. And if it's not 1, then we do not handle it. Like if it gets down to 0, then we just ignore it. And at the end, we simply just turn res. And I just noticed it's a long, so probably have to long. Yeah, let's do long this one as well. It's all long. So this times can do long on this. Okay. Let's see if this one works. Alright, it doesn't work. Second one works, the first one doesn't work. Very interesting. The first one does not work. Huh? Boom, 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 boom. boom, 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 boom. Dun, 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 dun. Why the first one output is 1? That's very interesting. Plus, I don't have to do this. This is just n. I have n. I didn't even use it. I don't know. Let's try one time. Yeah, equal to. Okay, so I'll first do some print debugging, which I will say print system.print line. I believe it should be arrays dot to string counter. That's what I want to see. Just a counter. Counter 2, 3, 4, 2, 1. Counter is right. Okay, counter is right. Next, I want to see current. Okay, so system out print line string format. So I'll do, this is current. Okay, I'll do current implementation and count. Okay, current imp counter current. That is bonkers. I got 4. Oh. Ha. It has to be, oh my bad. It has to be a priority queue. Ah, that's the reason. Okay, it has to be a priority queue. I mean, it's fine. I can do priority queue. So this is not a deck, but a priority queue. Then this is not. This has to be, because I need to know the count of edges, right? The count of edges. Because the other way won't work. Then how does topological sort work? It's like a tree, I think. So you don't have multiple things. That's okay. So, oh, then we don't need any of this. So I just do Q. Actually, I should call it PQ. Right, so it's a PQ dot add new int. Yeah, I also need to define how do we compare them. So it's going to be AB integer dot compare A0 be 0. And we want a yes minimum heap. So we're gonna do. Then why do you even need a graph, right? You don't even need this. You can just do not a set, because I just need to know. No, you do need it. You do need it. So it will be graph.get k dot size and k itself, right? Then we don't need any of this. Okay. And then we have this. So now we say, well, PQ is empty. PQ is empty, and we need to make sure that the top of the PQ is correct. So we might need to pop some stuff. So we say while PQ dot is empty, and top of, so PQ dot pull. Okay, pull 0 is the length is not equal to graph.get pq.pull 1, right? pq.pull graph.pq.pull.size, right? If that's the case, then say pq.remove pull. I just realized this is not pull, my bad. This should be peak. And this is also peak. Right, so we pick the top. If the count on the top, the size of its edges, current edges, is not equal to the size of the of it on the graph, then we need to just remove it. And at the end, we can say int current. It should be like this. Current equal to pq.pull. And then rest shall plus equal to the original size. I do need counter. Damn it. I do need counter, because I need the original size. So counter k equal to graph.get k.size. Alright. So we say be current 0. No, current 1. Because current 0 is the number of edges when it gets in, which is actually just 1, right? So if implementation do this, and then we do this, and then we do this, and we say yeah, we remove it and we'll put it in. Right, we're gonna say q, not pq dot add new int. It's going to be graph.get neighbor dot size, and then the neighbor itself. Okay, this shall be 1. I'll remove this. Right, so the current 0 basically is just used for the other purpose. And well, basically we remove 1 or push it in, right? And then the minimum come out, then I'll remove. Okay, let's try this one. So this is a different way of doing it. Cannot load from int array because I hit some value. And it is not allowed. It's interesting. How is that possible? Well, for one, this is not 50,000. This should be just n. Current pool 0 is the size. 1 should be the key. Don't know. You want to try again? Okay, I think I'll do the same thing. System.out.print line arrays.toString counter. Make sure the counters are right, and each time we can say system.out.print line arrays.toString current. Okay, let's see what current look like. So we go 43012. Yep. That shall be it. Current become null. Huh. Okay. So while true, if k dot is empty, break. Interesting. I never remember doing this for all the other situations. I guess I have to do it for this one. So it's like a little bit extra, right? A little bit extra in this. Two 285. Always pop out. Wait, why are you doing this then? You just count it. I have no idea why you're doing this. Seriously, I have no idea why you're doing this. We do the graph, right? And then we just need a int of int, right? So we say int counter because new int and 2. Don't need this, don't need this, don't need this. Counter no, I just need a size. But then we need to sort. Right, so yeah, it's okay. So this is gonna be new int so we'll put the size first. Oh, we put the size first. That's it. That's all we need. We just need a size. We just need a size. We just need the size. And then we say arrays.sort counter, right? And then we say for int I equal to 0 smaller than n plus plus okay, and then we say rest or plus equal to the counter, which we can actually just do long. Like, I don't know why we cannot just do long on the counter, right? Yeah, I guess to save memory, because this is much easier. We say basically long I plus 1 times long counter I. Right, and then we just return a result. And because of this, we don't even need to use, right? We don't need. All we need here is we can actually do a list. Not a list. No, I don't think we can do it that way. But we can definitely do a list of integer. Just do array list. Right. And do array list. Array list, we do this. And then we put the counts in, sort them, and then go through small to large. Yeah, I don't know why I thought the other way. Yeah. Doesn't even need priority queue, I don't know. Sort the nodes by the number of edges. And their order is their importance. Now we can argue how to get the size faster. Like, is map the best way to get, right? Apparently no, because I can just use counter, right? I can just use, because all I need is the count. So I don't need this, don't need this, right? All I need here is say counter E0 plus plus, right? And we say counter E1 plus plus. So after done that, we don't even need to do this. We sort it, go with the rest, go through everyone, do the multiplication, and return the result. Yeah, I think this will be sufficient. It's like 3 methods, right? 3 solutions in one sitting. Yeah, I think this shall work. Exactly, right? Exactly. You don't really need any of those fancy stuff that you were thinking about. Let's see if I did the same way last time. Yeah, the exact same way. Exactly. That's a good use. Sorting. Yes, yes, yes. Yes, 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 yes. Owen squared? Huh? How is Owen squared? Oh. Okay, but that's not my n. This is the n. N is the length of the roads. Right? N is the length of the roads. N is the length of the roads. So we do that. Ah, because the roads can be longer than. Okay, so this is actually not right. I agree. Depending on what your n is, O(n) squared is more correct. Yeah. Anyway, so that's it. All right, see you guys tomorrow. Adios.